We know that velocity has a direct relation with the field. Here we could equate them by putting a proportionality constant, which we call it mu or the mobility. So we replace this in the previous equation. Voltage and field are closely related concepts. In fact, if we imagine field being constant, we could say V is equal to E dot L. And we could replace this in the previous equation to get the following result. Pay attention. It says for a given voltage difference, how much current we have. For example, or for the example of water, we could just imagine that we have a pipe made of some material. If we raise one side with respect to the other, we have induced a potential difference or voltage at its both sides, and therefore water would flow. If we change the pipe and for the same voltage difference we have a greater current, we say the material conducts better. So we make an abstraction and we say, since this says I is equal to something times voltage, it means if that something is a bigger factor, then it means for the same voltage we could have a greater current. That's why we call that as the conductance. Obviously, the bigger it is, the bigger the current would be. And the parameter also makes sense. It says if the number of charges or water molecules, for the example of water, and area is higher, then we'd have a bigger current. Just imagine you have a pipe with bigger dimensions. Also, it says the higher the mobility, the higher the conductance, and obviously, or conductance, and obviously, the higher the current. We call the opposite of this conductance as the resistance. So we say, if we work out this example, the 1 over conductance being the resistance, we get Ri is equal to V, or R is equal to V over I. This is known as the Ohm's law. And obviously, it states that the current in a material under a given voltage difference has a relation with dimensions, mobility, and number of free charges per cubic meter, or the free charge density. This is why previously that we were talking about the silicon piece, we said why we need those free charges. You remember the reason that we got into all of these things was that we said because silicon atoms have the similar electronegativity, they would form the covalent bonds, and therefore at the zero temperature or absolute zero, we wouldn't have any free charges. The reason that free charges are important is because of this. So we could have current.